Welcome to America Reads Fun Learning Activities. We are college students who create learning activities for kids. Our fun activities are focused on writing, reading, and math. Thank you for joining us today. Today, we are going to be learning about greatest common factors, least common multiples, and distributive property. First, I want to show you how to find the greatest common factor and the least common multiple of two numbers. Let's start with finding the greatest common factor. Here's an example. Find the greatest common factor of 9 and 15. There are two main methods that we can use to find the greatest common factor of two or more numbers. The first method works better for relatively small numbers like these two, 9 and 15. For larger numbers, it still works, but it could potentially take longer. This first method is to simply write down all of the factor pairs for each number like so. Let's start with the number 9. Can you think of any of the factor pairs for the number 9? So the first one that we can think of is 1 and 9. So because 1 times 9 equals 9, 1 and 9 are a factor pair of 9. What else can you think of? Another factor pair of the number 9 is 3 times 3. Are there any other factor pairs that you can think of for the number 9? I think that's all, so let's move on to the number 15. For the number 15, we can start out again with the number 1 and 15. This is always the factor pair that we should start out with. 1 times the number itself. What other factor pairs can you think of for the number 15? One other factor pair for the number 15 is 3 and 5. Can you think of any other ones? I think that's all again for the number 15, so once we are sure that we have written down all of the possible factor pairs for each number, we need to find the largest number that appears on both lists. This is because we want to find the greatest common factor, or in other words, the largest factor that both of these numbers have in common. So let's look at our list now to see which is the number that they both have in common. I can see that both lists have the number 3 in common. They also both have the number 1 in common. However, since 3 is the larger number, 3 is the greatest common factor. However, since 3 is the larger number between 1 and 3, that means that 3 is the greatest common factor of 9 and 15. Let's try another example. You may have been wondering in the previous example why it is necessary to write 1 times 9 in the list of factor pairs for 9 and 1 times 15 in the list of factor pairs for 15. This is because sometimes the greatest common factor of a number can be the number itself. Here is an example of that. Let's find the greatest common factor of 6 and 12. We can do this the exact same way that we did this last time, by writing the factor pairs of each number. Let's start with the number 6. What are the factor pairs that you know of for the number 6? Of course, the first one that we need to include is always 1 times the number itself. So, what other factor pairs can you think of? Another factor pair of the number 6 is 3 and 2. Are there any other factor pairs that you can think of for the number 6? Now let's move on to the number 12. First, let's start out with 1 and 12 as our first factor pair. What other factor pairs can you think of for the number 12? Another factor pair of the number 12 could be 3 and 4. Are there any others that you can think of? Another one that I can think of is 6 and 2. Is there any more that you can think of? Once again, I think that we have found all the factor pairs for this number, so now let's compare our lists again. These lists have 1 in common. They also have 6 in common, 3 in common, as well as 2 in common. However, since we are finding the greatest common factor, we need to find the largest number that both of these lists have in common. So, the largest number that both of these lists have in common is 6. This means that 6 is the greatest common factor of 6 and 12. This example shows us why it's important to include the number itself in the list of factor pairs. Now, we can learn the other way to find the greatest common factor of 2 or more numbers. This way is faster when dealing with larger numbers, and the method is called prime factorization. In order to use this method, we need to remember what a prime number is. A prime number is any number that is divisible by only 1 and itself. For example, the first few prime numbers are 2, 3, 5, 7, and 11. We know that these are prime numbers because they are divisible only by their self and 1. What I mean by this is that the number 2, it can only be divided by 2 and itself. So in other words, if you divide 2 by 1, then you get 2. Or if you divide 2 by 2, then you get 1, but you cannot divide the number 2 by anything else. Now that we remember our prime numbers, let's learn how to do prime factorization. Let's find the greatest common factor of 20 and 50. To start off, we need to find the prime factorization of the number 20. The easiest way to do this is to make what is called a factor tree. I'll show you how to do that now. So we're going to start by writing our number 20 at the top. Then we're going to create a tree of factors underneath. In order to do this, we start by writing all of the factors of 20 that we can think of, circling the prime numbers as we go until we are left with only prime numbers. To start out with, what is a factor pair that you can think of for the number 20? The first factor pair that I think of for the number 20 is 2 times 10. Now we have already found one prime number. That prime number is the number 2, so let's circle that. And now let's continue with the number 10. What's a factor pair that you can think of for the number 10? Factor pair that I can think of for the number 10 is 2 times 5. Now both 2 and 5 are prime numbers, so we can circle both of these. Now we can see that we are left with only prime numbers. Therefore, we have found the prime factorization of the number 20. We can continue on with the number 50 now. And let's do the same exact thing that we did before. What are some factor pairs of 50 that you can think of? Something that is helpful to think about when you're finding a prime factor is to see if the number is divisible by the number 2 to start out with. So we know that a factor pair of the number 50 is 2 times 25. Then again, we have the number 2, which is a prime number, so we can circle it. And again, we have the number 2, so we can circle that because it's a prime number. Now let's move on with number 25. Now 25 can't be divided by 2, so we have to think of something different this time. What factor pairs can you think of for the number 25? The factor pair of 25 is 5 times 5. Again, we are left with 2 prime numbers here, so we can circle them both. And now we have successfully completed the prime factorization for the number 50 as well. Now, once we have found the prime factorization for each of these numbers, what we need to do is underline the numbers that they have in common. So I can see that they both have the number 2 in common. So let's underline those. Now, although there is another 2 here, we can only underline this if there was another 2 as well on the other side. So we can't underline this 2 just because there is a 2 here as well. However, they both do have 1 5 in common, so we can underline both of these. Now that we have underlined all the numbers that they have in common, we need to multiply these numbers together. So 2 times 5 equals 10. So this means that the greatest common factor of 20 and 50 is 10. Now we have found the greatest common factor of these numbers using prime factorization. Now that we have learned these two methods to find the greatest common factor, let's try finding the least common multiple of two numbers. Here is an example. Find the least common multiple of the numbers 6 and 8. In order to find the least common multiple of two or more numbers, we should start out by writing the multiples of each number. And I will show you how to do that. Let's start with the number 6. In order to find the multiples of a number, we need to start out by multiplying that number by different things, and each number that we multiply it by makes it a multiple of that number. For example, let's take 6 times 1 for example. 6 times 1 is 6. So 6 is the first multiple of the number 6. Next, we can move on by just going up one number. So 6 times 2 is 12. So that is the next multiple of the number 6. Let's continue on. What would be the next multiple of the number 6? The next multiple, which would be 6 times 3, is 18. Let's go up until we find 5 multiples of the number 6 to start out with. What would be the next multiple for the number 6? 6 times 4 is 24. Then, if we go up to the 5th one, 6 times 5 is 30. Now let's do the same thing for the number 8. What is the first multiple of the number 8? 8 times 1 is 8, so that is the first multiple of the number 8. What would be the next multiple? 8 times 2 is 16, so that would be the second multiple of the number 8. Then what would be the third one? 8 times 3 is 24, so that's the next multiple of the number 8. Then let's go up to 5 again. 8 times 4 is 32, so that's the next multiple. Then 8 times 5 is 40. So now we have created a list of multiples for each of these numbers. And we can see if we can find a multiple that the two numbers have in common. If not, then we can continue writing more multiples until we find a number that they have in common. So it looks like we have already found one. The number 24 is both a multiple of the number 6 as well as a multiple of the number 8. So let's underline that in both lists. "24 is also the lowest number that we can find that they both have in common, which makes it the least common multiple. Now that we understand greatest common factors and least common multiples, let's learn about the distributive property. The distributive property may sound a little bit confusing at first. However, once we see the examples, it will start to make more sense. The distributive property is what tells us that x times y plus z is equal to x times y plus x times z. Let's look at an example so that this will make a little bit more sense. if we have 4 times 3 plus 6, then the distributive property tells us that this is equal to 4 times 3 plus 4 times 6. So another way that we can look at this is that when we have a number outside of our parentheses and inside of the parentheses we have two numbers being added together, the way that we can multiply those is by distributing the 4 across the parentheses. So we can draw an arrow to show us how that looks like. So let's draw an arrow to show us what that looks like. We would have 4 times 3, and then we would have 4 times 6. And that's the same thing that we have over here. And that's what the distributive property tells us. Let's look at an example of how to use the distributive property to write an expression like this. Let's look at an example of how to do this. Our problem says, rewrite using the distributive property, 72 plus 40. So how we would start out is to start by finding the greatest common factor of these two numbers. Let's do this the same that we did before with the prime factorization. We can start with the number 72. And let's draw our tree. So, like before, we can start by thinking if this number is divisible by the number of 2, and it is. So 2 times 36 is 72. And we can circle the number 2 because it is a prime number. And we can move on with the number 36. What are some factors of the number 36? Again, if we try dividing it by 2, we would find that 2 times 18 is 36, and we can circle the number 2 again. Then let's continue with 18. What factors can you think of for the number 18? We can do 2 and 9. Now we are left with the number 9, and we know that 3 and 3 are factors of the number 9, and both of these are prime numbers, so we can circle those. Both of these are prime numbers, so we can circle those. Now we have finished the prime factorization for the number 72, and let's move on with the number 40. What are some factors that you can think of for the number 40? We can start out with 2 and 20. Once again, we know that our number 2 is a prime number, so we can circle that one, and let's move on with the number 20. This is divisible by 2 again, so we can do 2 and 10. And then we can circle the number 2 again and move on with 10. Once again, we have a number that is divisible by 2, which would be 2 and 5. So we can circle both of these because they are both prime numbers. And now we have completed the prime factorization for the number 40. Now let's see again which prime factors these two numbers have in common. On each side, we can see the number 2 here, so we can underline both of those. What else can we see? They have the number 2 in common again, so we can underline it once more. So we can underline that once more. What other numbers do you see that these both have in common? Yet again, they have the number 2 in common. So let's underline those one more time on each side. Do you see any more numbers that both of these trees have in common? So we know that we need to multiply 2 times 2 times 2 in order to find the greatest common factor of these two numbers. 2 times 2 times 2. So we know that 2 times 2 is equal to 4. So we then can have 4 times 2. What is 4 times 2? 4 times 2 is 8. So we know that the prime factor of 72 and 40 is 8. So now, in order to rewrite this expression using the distributive property, we need to factor the number 8 out of these two numbers. Essentially, what this means is that we need to divide both of these numbers by 8. So if we have 72 plus 40, and we want to factor out the number 8, we're going to be left with 8, and then in the parentheses, we want to have two numbers added together. So the way that we want to rewrite this expression is by factoring out the number 8, and in parentheses, we want to have two numbers being added together. And we know that we want this expression to be equal to 72 plus 40. So what we need to do is figure out 8 times what number is 72, and 8 times what number is 40. What times 8 is equal to 72? We know that 8 times 9 is equal to 72. So, what times 8 is equal to 40? 8 times 5 is 40, so we can plug that in as well. Now this gives us our expression that is equal to 72 plus 40. So if we rewrite the expression 72 plus 40 using the distributive property, we get this expression here. That is all we are going to do for today, and I hope you feel ready to find greatest common factors, least common multiples, and to use them to write expressions using the distributive property. Thank you for learning with me today. I hope you come back and learn some more. Please comment if you have any questions, like and subscribe to our channel, and we will be back with more videos.